Good afternoon, everyone. This is Elisa Baum. I'm GridGain Systems Director of Product Marketing. We'll begin in just a moment, but first I'd like to conduct just a little bit of housekeeping. First, can you please raise your hand using the hand icon located in the GoToWebinar control panel to let me know if you can hear me? Let me see. Can you guys hear me? Yes, you can. That's great. Next, during this webinar, you will be on mute, but should you have any questions during the discussion, please enter them in the questions field within the control panel. At the end of the webinar, we will take time to answer as many questions as possible, and those that aren't addressed will be answered in a follow-up blog entry on GridGain Systems blog. In addition, a recording of this webinar and the presentation slides will be made available to everyone within 48 hours. With that said, I'd like to thank you for attending today's webinar, Apache Ignite Web Console, Automating RDBMS Integration. It's being presented by Dennis Magda. He is our product manager, GridGain Systems product manager, and he's also an Apache Ignite PMC chair. So with that said, I will turn the floor over to Dennis. Go ahead, Dennis.
Hello, Elisa. Hello, everyone. Thanks for the introduction. Thanks for everyone to attend this webinar. And guys, I think that it will be extremely useful for you. Because to be honest, today I am planning to talk less and show more. I plan to share with you my experience I got while I was working with a variety of Apache Ignite and GridGain users, helping them out to migrate from a relational database architecture to a data grid-based architecture. And you know, during all of these migrations, me as well as the users and customers faced with a difficulty on how to easily migrate your database, how to easily migrate your database scheme to Apache Ignite's presentation, how to easily set up indexes, how to easily preload the data. And all of these issues, all of these problems can already be addressed with Web Console, which automates all these things for you. And plan for today is to give you a brief reminder, a brief introduction of what Apache Ignite is, what is Apache Ignite Web Console tool, what you can get from it, and how can you leverage from it in your environment. And once I do this introduction from you, I will switch to the demo and we'll show you, and we'll do a kind of walkthrough guide showing how we can connect to an existing database from Web Console side, how we can migrate data from there, and how finally we can connect to this database from an auto-generated project and preload our data into the cluster. Having said this, let's give a brief introduction on what Apache Ignite Data Fabric is. So, in a nutshell, Apache Ignite is in-memory data fabric. It's a distributed system that consists of several distributed components, such as data grid, compute grid, SQL grid, and more. The foundation of in-memory data fabric is for sure the data grid, which gives us a basis for uniform data spreading across the cluster. And once your data is spread out across the cluster uniformly, you can benefit from the rest of the components of the data grid that will perform all the computations, all the query executions cluster-wide in a fault-tolerant and distributed way. During our today talk, we are mostly going to pay the attention to the in-memory data grid, which is shown on the current slide. And the data grid basically is a distributed key value data store. You can think of it as of a distributed hash table, where every key belongs to a specific distributed node. And when you want to work with the data, when you want to get a key, or when you want to update the value for a specific key, you will work with a specific node located in your cluster. Apache Ignite Data Grid handles and guarantees handles data reliability for you. So it provides you with an ability to set a number of backups for your data set, which means that at every given point of time, every key will be stored on a primary node that hosts a primary copy of the key, and there may be one or more backup copies of the same key located cluster-wide. This is essential for the situation when you want to get high availability guarantees and fault tolerance guarantees from the data grid. And what else is worth to mention about the data grid is that if you want to work with your data in a transactional way, we have everything for you to support this scenario, because InMemory data grid is fully a seed compliant system. So you can execute distributed transactions across the whole of your cluster, and the data grid will guarantee that a transaction will be either fully committed or it will be rolled back if some of the nodes was not able to commit some part of the value on its side. What's else related to our today webinar is how Apache Ignite InMemory data grid persists data on the disk layer. If you take a look at this picture to the right, you will see that you can tie up Ignite InMemory cache with a persistent storage, which can be a relational database or NoSQL database or Cassandra or Hadoop, whatever you like most. And today during the webinar, we are planning to integrate our InMemory data grid with a relational database. I chose MySQL for the sake of the webinar. And the next slide describes how InMemory data grid works with the persistence layer. We have a special interface which is called CashStore. It's really straightforward to implement it because it exposes several interface methods that are needed for data grid in order to get data from a database, to put an update to the database, or to delete a value from the database. When we talk about relational databases, then here your life will be even simpler, because Apache Ignite provides an out-of-the-box implementation for any JDBC compliant relational database of the CashStore interface. So today we plan to use so-called cache POJO store implementation that we just need to configure in our cluster configuration, and our POJO store will handle all the communication with an underlying MySQL database for us. Also, throughout the webinar, I plan to show how the read-through and write-through capabilities work in practice. So initially, when our cluster is connected with the database, we will try to preload the data from it so that all the data resides in memory. Later on, when I will be trying to update the data in the data grid layer, we will make sure that all the updates that happen in memory will be propagated to disk, to our MySQL storage. And as for the query APIs, today I'm planning to rely only on InMemory SQL Grid capabilities. And just to show I hope that a lot of the people who work with the relational databases are accustomed to work with SQL language. And thanks to Apache Ignite, we can leverage from it SQL Grid engine, which is ANSI 99 compliant. And thanks to this engine, you can easily reuse your knowledge you got while you were working with relational databases, because you will not be required to re-implement whole your application from scratch. You can reuse the same queries you used for your, let's say, MySQL database, making sure that all these queries satisfy ANSI 99 specification. What else worth to mention about the InMemory SQL Grid is that it's truly cross-platform solution. Ignite does provide native APIs for SQL Grid for its own Java, .NET, and C++ libraries. However, if you prefer to work with JDBC or DBC drivers, or if you want to connect from your favorite language like PHP, Python, Ruby, or from your favorite tool like Tableau or Zeppelin, then you can easily achieve this with InMemory SQL Grid by relying on Apache Ignite's JDBC and ODBC drivers. And for instance, if you have today, I'm going to connect after I preload the data from my SQL database. I'm going to connect to my cluster from Web Console side, and I will show you how to query the data using SQL Grid capabilities, and at the same time update your data with data modification language statements like insert, update, and delete. And all this means that in practice, you can connect to InMemory data grid to Apache Ignite cluster from, let's say, your PHP application, from your Python application, which are not natively supported by Ignite yet, and still you can connect from there and execute your SQL queries. So, a couple of words about Apache Ignite Web Console. This is the new tool that became available in Apache Ignite recently. In short, this tool allows you to fully configure your cluster using a configuration wizard. Even more, during at the configuration time, as we are going to see today, you can connect to your existing relational database and import a scheme of your database, automatically set up indexes, and do a variety of other things that can be simplified and automated. After you configure your cluster and import a scheme of your database with all of the indexes, you can download a ready-to-be-used project generated by Web Console. And that project will include all the configurations needed for you to start working with your cluster. And once your cluster is up and running, you can connect to it from Web Console side and execute queries over there. And also presently, you will be able to see who works with your cluster, who connects to it. This feature is available under admin panel, and it's good to have it for your company's administrators. And later on, we constantly work our Apache Ignite, several guys from our Apache Ignite community constantly improve Apache Ignite Web Console. And so going forward, you can expect much more features, much more functionality available under this tool. To start working with the tool, you have options to do. The first one is that you can go to Apache Ignite, download the latest release, build and deploy the web console on your own environment. Let it be a cloud environment or your own hardware. It's up to you. The simplest approach that I like more, especially when you start learning something new, is to use something that is already deployed for you. For instance, GridGain is as one of the many contributors of Apache Ignite. Has an instance of Apache Ignite Web Console deployed on its own hardware, and you, as an Apache Ignite user, can go to this deployment, can use this deployment, and play with Web Console, checking all the capabilities that are presently supported. And even more, GridGain's Web Console allows you to use for free some of the features that are supported by GridGain plugin developed for Ignite Web Console. For instance, presently you can monitor the state of your cluster from GridGain Web Console deployment only, but if you go to GridGain site, you can use it for free. A bit more details on how technically Web Console communicates to a database or to your cluster is shown on this slide. So let's imagine that your console is deployed on some hardware, and then you open up a browser and go to your Web Console deployment. Web Console communicates to with your browser over WebSocket interface. And also, after that, every request that is received from your browser site, Web Console redirects to a special application called Web Console Agent. It's a Java application that is deployed in between of your Web Console and your database or your Apache Ignite cluster that is not shown on this picture, but it should be to the right as well. And Web Console Agent receives all the requests from Web Console side and sends a specific request either to Apache Ignite cluster or to a relational database. It will connect to a relational database in an occasion when you need to import the data, import scheme, import indexes from your underlying database. This is what we are going to show today during our webinar. So this is all from theoretical part. Now let's switch to the demo. Let me switch the screen. Give me a second, please. Okay, Alisa, can you see my screen?
Yes, Dennis.
Okay, that's great. Okay, guys, today, as I already said, I'm going to deploy data from my MySQL database running on my laptop. So let me start the database. After the database is started, let's connect to it and make sure that there is a database of internet of our interest which is up and running. Okay, we are connected to the MySQL server, and let's check that we have some tables over here. For instance, this is a table of all the employees. We show the first 10 rows, and as for this database, it's an exemplary database that you can Google for in the internet, and this database usually used for the scenarios when you want to test your MySQL, PostgreSQL, or other relational database solution. Okay, so now let's go to the Web Console. It's time to import a scheme and indexes from this database and to integrate with it after that. So you can find information about Ignite Web Console on Apache Ignite main site. So you need to go to Manage, tab and click on Ignite Web Console. After that, here you have two options. You either need to build Web Console and deploy on your own, or we can just leverage from the instance of Web Console already deployed on GridGain side. So this is what I'm planning to do for today. So here it is. This is our Web Console. It includes several tabs. Let's review them. The first one is Configure tab. This tab will be used by us for the initially. So we are going to configure. We are planning to create a configuration for our cluster and use it after that. Next, once our cluster will be up and running, we will execute several queries, which using interface available under Queries tab. And later on, also when we will connect to our cluster and monitor its state, as well as queries that were executed against it.
Dennis, I hate to interrupt you. We're being asked if you can make the image bigger or full screen.
Okay, let me try to. Does it look better?
That looks better. Thank you.
Okay, great. Good. Okay, so let's create a configuration for our cluster. Here we need to configure a basic configuration. Let's name our cluster somehow. I will name it Ignite Cluster. On this screen, I'm planning to change a discovery method for the nodes of my cluster. By default, Ignite uses multicast IP finder, which requires the multicast protocol to be enabled in your environment. But usually it's more than enough to use static IP finder, where you just need to list IP addresses and port combinations of all of your cluster nodes you expect to join your cluster for a while. So let me adjust a list of the ports addresses, reducing it to, let's say, I don't expect to launch more than 4 nodes for today. So, and once this update happens, you can see that Web Console automatically updates the configuration for us on the fly. So when we get to the final point, we will be using TCP Discovery VM IP Finder for the nodes discovery purposes. Next, let's go to the, okay, I need to save. Don't forget to save your changes. Here is our cluster. The most interesting part. Let's import the data from our MySQL database. So let's click on Import tab button, and here you will see a kind of a pop-up dialog that asks us to download the Ignite Web Agent. You do remember this web agent, and this web agent will be needed for us to connect Web Console to our MySQL database at the time when we will be populating, when we will be importing the scheme of our database. So the agent was downloaded. It's located over here. And now let's, what else? Let's review its content. Basically, the agent, I don't need it. Basically, this agent contains properties files. Also, there is a runnable jar file and a couple of executable scripts. Also, it was to talk about JDBC drivers folder, where we have to copy a JDBC driver of a database we are planning to connect to. As for MySQL database, we need to copy a JDBC driver of MySQL connector that can be freely downloaded. So let me just copy paste it to that folder. So okay, so The MySQL driver is over here, and now we are ready to start. Let me increase the font. And now we are ready to start our Ignite Web agent. So what's going on over here? So Ignite Web agent will connect to the cluster, which is running locally. This is shown in this row. Also, the agent will connect to the Ignite Web Console instance deployed over here. We are using Grid Gain console, so if you want Ignite Web agent to connect to your own instance of Ignite Web Console, then you need to go to properties files and adjust some settings over here. Okay, so going back to the Web Console, you see that Web Console can successfully connected to the agent. And here we need to specify a number of parameters. So this is how our JDBC URL will look like. So we are going to connect to MySQL and retrieve data from employees scheme. And here is user and password required by MySQL server. Oops, something goes wrong. Let me double check. Okay, now everything is fine. Looks like that the password was incorrect. Next, guys. So here you see that MySQL actually contains several schemes, but we are interested only in employee scheme. Let's import it. We are planning to import all the tables, and for every table we are going to create a correspondent cache with a specific configuration. Every cache will be partitioned, and later on I will show you how you can adjust several settings related to a specific cache. But for now, for every table, we will create a related cache that will be deployed on Apache Ignite side. Here you can do just fine-tune, advanced tuning before the importing finalized. For instance, this property says that if we see that your primary key is a simple one, meaning that it's a kind of single column key, then the console will use integer and Java built-in simple types like integer, long, and string, and will avoid creation of custom complex keys for you. Also, we can do additional optimizations. Let's say that if one of your column can be null, then a corresponding field that will be created for you automatically will be of Java primitive type. Like, let's say that you have an integer column in your database which can be null, and for the same column you will have a kind of field in your POJO Java object, and the field types will be primitive. This is just to make the next property generates aliases for you. Actually, I don't need this. I will uncheck this stuff and generate POJO classes property. Will allow console to generate custom POJO classes for you so that you can reuse them later on in your source code. That's all for now. And now you see that the model, the scheme and the model has been imported for us. Here, what we can review. So you can see that, let's take a look at salaries model, for instance. You can see that for salaries model, we created a custom key because in our database, a primary key of salaries database consists of several columns. Also, the Web Console generated a custom class for the value object. It will include different value fields. This class will be stored in salaries cache. meaning that the objects of this type, of salaries type, will be stored in this cache. And here below we list fields that will be queried by SQL queries. So if you are not planning to query, let's say, some of the fields directly in your SQL query, then you can remove it from here. Also over here you can specify additional indexes. As you see, Web Console imported a kind of custom complex index from the database, but let's add one more additional indexes for us, for, let's say, for salary field, or for employee, or for employee. Let's index employee, and it will be added to our configuration immediately. The other property is how this data grid will be integrated with our MySQL. So here we provide configuration that is required to map data from MySQL representation to data grids representation and vice versa. So let's save it for now. Also, if to go to caches configurations, there you will see that Web Console populated cache configurations for us. If to take a look at, for instance, an employee's cache, here you can change, let's say, atomicity mode, setting it to transactional. Or you can say that I want to store all employees in the off-heap region, which will be unlimited. What else interesting, what also I'm going to demonstrate during the webinar is how you can monitor the queries that were executed across your cluster. And to enable this functionality, we need to set this history size parameter to a non-zero value. Let's say that we want to monitor, we want to keep 50 latest queries for the monitoring purposes. Let's do this change for, apply this change for employees cache. And also let's monitor the queries that will be executed against salaries cache. We will skip the next configuration parameters, which are for InMemory file system and the others that are related to GridGain plugin. I'm going to summary page directly. So this summary page provides you a complete configuration, XML configuration created for server nodes as well as client nodes. Also here you can find the configuration in the form of Java, as well as POM files and Docker files that might be useful for your scenario. And today, let's download the generated project and try to connect to our database, importing data from there. So here is, where is my example? Here is my example. Let me open it from IntelliJ IDEA. Downloads, Ignite cluster. Okay, looking at the source code, here you will find, here you can find simple startup files that you can use to start a server node or let's say a client node using a configuration generated by Web Console. All the configuration is located under meta.inf folder. For instance, here we have a configuration created for server nodes, and this is for the client nodes. In addition, there is a useful Java source file that will be used for us for the data preloading from MySQL side. So we will use this load caches file to connect to the cluster in the client mode and preload the data for all of the caches we defined so far. The other packages include POJO objects generated by Web Console for us, and the same configuration for our server and client nodes in the form of Java Ignite configuration. Okay, so before we proceed with the cluster startup, we need to define several parameters needed to connect to our MySQL database properly. So let me just copy paste them over here. And now let me start my first server node. Okay, while the project is being compiled and the node is being start up, let me go to the next tab, the monitoring tab, and show you how you can review the state of your cluster. So as soon as the first node is up and running, our Web Console will be able to connect to it via the web agent and to show this information. Here it is. Here you see that we have a single node where we are going to deploy all of these six caches. And also what's interesting to note is that you can monitor the usage of your CPU and heap. You can monitor the size of all of your caches. At the moment, all the caches are empty. So let's start preloading the data to our caches from the MySQL database. All we need to do is to start this load caches file prepared for us by Web Console and wait while the caches will be populated. While the preloading happens, let me show you how you can tune your monitoring tab. You can, if for example, you want to see the average max heap usage, you need to check on this tab. Also, you might be interested to monitor CPU busy time. If you want to see a variety of cache metrics, you can enable them over here. And as for the cache sizes, if let's say you are not interested in the size occupied by backup nodes, you can uncheck this button. Okay, guys, as you see, we see that the size of our heap keeps growing. It means that our client node got connected to the cluster, and now it preloads the data to our caches. We have already preloaded most of the caches, and now we keep preloading the salaries caches. Basically, I think that it's enough for us, so I'm not going to wait while all the data gets preloaded from MySQL. Now let's me go to the next step, to the queries tab. I've already prepared several queries over here. The first one will select a value of the key and first name, last name of the first 10 employees stored in memory. So let me mention that presently all these queries are executed over the data stored in memory. So the queries are not executed over the MySQL. We will go to MySQL only if we will update data in memory, or if we request a key which value is not preloaded in memory yet. So here you can see that we have a kind of several users. This is a kind of the primary key, which is a cache key in terms of data grid. And now let's use data modification language capabilities, updating one of these one of these entries. So let's say that I want to update let's say the first record that that corresponds to this key. I want to change the name to Tom Smith. The query was executed successfully, and now let's check that this entry was really updated. Let's execute this query. Yeah, it works fine. And also, I know that my data grid writes through all the updates to my MySQL database, and now I want to be sure that this record was updated on MySQL side. To check this, let me go to my MySQL connection and check that this record now got updated. Here it is. You see that the update was populated to the database layer as well. This happens automatically. Also, what's else to note? We can execute. Let's say we can delete rows. Let's, for instance, delete this record related to Pat Bamford. So let me delete it. The web console says that everything went well. Let's double check it. Okay, here it is. We no longer see the record of 10003. And let's double check that the record was deleted on MySQL side. Our previous execution shows that the record was there. And if I re-instantiate the query, I will see that this key was completely deleted from my MySQL database as well. And finally, for sure, you can execute Ignite. SQL Grid is famous of its SQL capabilities. Especially, you can join the data located in spread out across several caches. And here we are going to join the data located in salaries cache as well as in employees cache. And we want to get all the salaries records for the guy with this ID. Here it is. Later on, after the webinar, you can play with this console, but we no longer have enough time to cover all the capabilities of this window. And the last thing I want to show you is queries monitoring page. We were executing several queries, and all of these queries were recorded by DataGrid for us. And if you go to this monitoring queries tab, here you will see all the queries executed so far. Total number of times, the execution time, the latest time when the query arrived to the data grid for the execution, and so on and so forth. What's else interesting here is that if you have a long-running queries, you also can go to this tab and cancel them if it's needed. So basically, guys, this is all from my side. I hope that you formed an understanding that it's really straightforward to import, to create a configuration with the usage of Web Console, and to tidy it up this configuration with your existing database. And once you configure your cluster, as you see, you can leverage from this auto-generated project, taking the templates, configurations from there, and start working with your cluster immediately. So it took me, if to be more precise, it took me 25 minutes to do this, explaining everything in details for you, but in real life, it should have taken even less time. Thanks for your attendance, and if you have any questions, I will be happy to answer them.
Hi, Dennis. Okay, I'll read you the questions. The first one is, can Web Console generate C classes Visual Studio SLN?
Presently, this is not supported yet, but as far as I know, Apache Ignite .NET and C++ contributors who are part of Apache Ignite community plan to support this in the future. I think that it will be done by the Apache Ignite community this year. You just need to go to Apache Ignite and ask directly when to expect this functionality.
Okay, next question is, I wonder how to deal with database updates done by anything other than Apache Ignite when the data has already been downloaded in cache.
So basically, our recommendation is if you tied up your cluster, your in-memory cluster with your database, then it's recommended for all of the updates go through the cluster side, so that the cluster will keep in sync the data that is in memory and in your database layer. However, if by some reason your database gets updated from other application, then you have to propagate these updates to in-memory data grid somehow. Basically, there are a variety of options on how to do this. Depending on the kind of your database, you can record the changes that were applied and send them to the cluster. But the general recommendation, if you can avoid this architecture, it will be better if all the updates go through Apache Ignite cluster, and Apache Ignite cluster in its turn will keep in sync your database.
Okay, next question. In the key value pair construct, can the value part itself be a structure or just a single element?
Value is your custom object, basically. It includes several fields. Let me go back to the project that was generated by the Web Console to show you. So let's say that here for salaries we have this object. It includes all the fields that are related to it, like salary and to date. And when this object is being serialized and stored, added to the cache, it is stored in so-called binary format, in a cross-platform binary format, which means that you can put this object from your Java application, and later on you can read and recreate this object on your C++ or .NET side. But basically, this is how a kind of ordinary data model object looks like salaries, like employees. It's simply an object with a list of fields that are related to it.
Okay, the next question. Does a local deployment of Web Console need MongoDB to be installed?
Yes, it does.
Okay. Is that the answer? Move on to the next question. Yeah. Okay. Is it POJOs? POJOs created have Java convention properties. Is there a way we can get properties the same as DB column names?
So this convention is just to these properties were named just to satisfy Java convention, but it's up to you how you prefer to name them. And during the, let me show you, during the importing stage, you can specify aliases for your data model object and use these aliases in your SQL queries if it's needed. And these aliases are not required to satisfy Java convention or any other of its kind. Okay.
Okay, sorry about that. I was on mute. The foreign key relationships in the underlying database, are they maintained in cluster?
In cluster, we don't have any foreign key related or similar dependencies, meaning that if your data is kind of follows some foreign key restriction on the database side, this restriction will not be followed on the cluster side. So they don't implement such a capability. But basically, in the real life scenarios, in the real production scenarios, no one, to my knowledge, in my own experience, has complained that this is the feature that someone must to have.
Okay, the next question. If I have multiple gigabytes of data to load in cache at startup, what is the best way to do it? I assume JDBC way will be too slow.
So the preloading, there are several preloading techniques. So in this example, we used CashStore interface, and this cache, when you have multiple cluster nodes, let's say that you have 10 nodes, then the preloading will happen in parallel on all of the nodes. And every node will preload only its portion of data in memory, meaning that you can significantly accelerate your preloading. Your preloading will be faster if you have more cluster nodes. The other approach, if you don't want to use CashStore implementation, like JDBC-based implementation for preloading purposes, you can leverage from Ignite Data Streamer approach. Ignite Data Streamer, it's a kind of fast way to preload any kind of data into Ignite cluster. So you can create an instance of this Ignite Data Streamer and feed all the rows from your database to it. This is the other approach that you can use in practice. But generally, preloading of gigabytes and hundreds of gigabytes, it's not a kind of difficult thing to do with any kind of preloading techniques. That should be CashStore based preloading or Ignite Data Streamer based preloading.
Okay, and the next question. Do you have any performance benchmarks for using Ignite on top of a relational database compared to using that relational database directly?
Basically, Apache Ignite does not compete to relational databases. This is why we don't do any official benchmarks comparing Apache Ignite to, let's say, MySQL, PostgreSQL. It's not of our interest. However, here you can, if you are interested in doing so, I can give you just some hints. You can use Apache Ignite YASIC framework that is open source and can be used by anyone for Apache Ignite benchmarking purposes. And you need to make sure that if you decide to compare Apache Ignite with a relational database, you have to instantiate kind of your cluster has to be not a single node cluster, because you get benefits from Ignite when you have a cluster of distributed machines. So the outcome is that you need just to start up your cluster of several machines, benchmark it, and compare the results for let's say, MySQL deployment or Postgres deployment. But in general, why Apache Ignite users prefer and switch to Apache Ignite? This is exactly because of its performance benefits. Because once all your data is in memory and spread out across your cluster, you will get significant performance benefits. If these were not true, we would not have been talking right now at the moment, because it would mean that relational database can handle all the scalability issues on their own.
Okay, we have time for a couple more questions. And if Dennis doesn't get to your question, I'll make sure he gets a copy of your questions and we'll address them on our follow-up blog post. Okay, so the next question is, can you specify different data partitioning methods for loading nodes in a cluster? For example, round robin partitioned by data elements.
So in Ignite, the partitioning is handled by so-called affinity function, which uniformly spread out data across the cluster. And by default, I just recommend to use it as is, without any modifications on its side. However, in some of the scenarios, you might need to place data of one cache close to the data of the other cache. If, for instance, you plan to execute SQL queries with distributed joins, and you're going to join the data located in employees cache as well as on departments cache, then you need to make sure that a specific department is properly collocated with the employees that belong to this department. And here you have several techniques. We have a concept of so-called affinity key. We have affinity key annotation. So basically, for an employee, you can create a custom key, complex custom key, and this key will include ID of your employee and ID of the corresponding department. And this department will be the affinity key, which means that when this employee will be placed into the cache, it will be added and located on the same node where the designated department is located, kind of this. And also, affinity key can be defined using binary configuration. Here, I would recommend, to get more details on how to use affinity key by relying on the annotation or on a specific binary configuration method, I would recommend to go to Apache Ignite RDBMS site. And if anything is unclear here, you can ask us a question on the user or dev list, and we will be pleased to assist you if something is unclear or need more information to provide.
Okay, and the last question for today. I want to confirm that using ODBC, any BI tool should be able to connect to the cluster. In 1.6 version, we were told it was only tested with Tableau.
Basically, now ODBC, let me just share with you a couple of official documentation. So as you said, ODBC, we have already tested it, and it's officially supported by Tableau. And even more, you can go to, let me open up. You can go to the documentation.
Hey, Dennis, I don't see your screen.
Okay, 1 second. Hold on. Can you see it now? Documentation.
No, I don't see it.
And now?
I see it.
Okay. So as for Tableau, right? So it's already supported and well maintained. And at the same time, when I was talking about SQL Grid, I told that you can connect to the Apache Ignite cluster from a language from your favorite language, and here we have a documentation created for PHP. Here we specify how you can. Here we describe how you can connect from your PHP application side using the same ODBC driver and start working with your cluster. So, for instance, you can. It means that basically this is proved for us. This is kind of a proof for us that a DBC driver is a kind of generic one. It can be used not only from Tableau, but it can be used from, let's say, from PHP side or from Python side or from other tools side. And so if you would like to keep playing with PHP, here you can just find advanced configurations. So here we show how you can connect to the cluster from PHP side using a DBC driver, and later how you can execute kind of well-known data modification language queries like insert, like update, like select and delete, and so on and so forth. And all these queries will be executed via our Apache Ignite DBC driver.
Okay, great. Well, that brings us to the top of the hour. There's a couple questions that I will address, and I will be sending out a link to the recording of this webinar afterwards. I need to process it, but I'll get that out by tomorrow. So that answers one question. And then someone asked about the SQL Grid. We are actually having, Dennis is coming back on March 15 to do an in-depth webinar on the Apache Ignite SQL Grid. So I invite you to go to www.gridgain.com and register for that, and you'll get tons of information during that webinar. And there's also quite a bit of information on our website as well. So with that said, Dennis, thank you for a great demonstration today. And audience, thank you for for participating. We really appreciate all your questions, and we hope to see you on another webinar. Dennis, thanks again.
Yeah, thanks everyone for attendance, and don't hesitate to write to our Apache Ignite user and dev list or directly to me if you want to provide feedback or you have additional questions. And look forward to see you during my next webinars, where we are going to cover, like Alisa mentioned, SQL Grid as well as microservices-based architectures.